Alright, this begins our lecture on section 5.2. Section 5.2 is about functions, and our objective here is to know the meaning of a function, of a relation, the domain and the range, and what a function is, and finding sets of ordered pairs and graphs. We're going to be identifying a function using a vertical line test. We're going to find out what the definition of a linear function is, and we're going to revisit our rule of fours in this investigation. A relation, first of all, is just a set of ordered pairs. And so anything that relates one set of numbers to another set of numbers is called a relation. A function is a special relation. It's a relation for which every value of the independent variable, the values that can be inputted, the x's that we usually call, and has only one value for the dependent, the values that are outputted, the dependent, those that are dependent upon the input, the y values. And these possible values of the independent variable form what we call the domain, and the dependent variables, the possible values that come out, are called the range. And a machine's like a function is like a machine, that once you put something in, you can't get something out that's different. So we're going to look at a function in terms of the rules of fours. So remember, rule of fours means we can describe something with words, we can describe it with sets of ordered pairs, we can describe it with graphs, we can describe it with formulas. So we're going to talk about a function in these terms. So first of all, we can describe a function in terms of words. The average population of a city from the turn of the 20th century to the present day. So population is dependent upon the time. And then we could also do a function by a table, and you see that the x's and the y's represent the ordered pairs. And then a graph, we can graph the ordered pairs on a number line or on a coordinate system, and then we could represent it like a formula, like the linear equations in two variables that we've been seeing for the last few sections and back as early as chapter 1. Now, one of the things that we're interested in is a set of ordered pairs actually a function, because remember, every set of ordered pairs is a relation, but only some relations are functions. So how can we tell? So one of the ways to tell is that for every value in the domain, there is only one value in the range. In other words, for every x, there's only one y. So if we're going to look at a set of ordered pairs, if we go through and we see there are no repeated x's, then we don't have to check any further. No repeated x's means it's a function. And we can see that in a set of ordered pairs by just taking a look at the x's, right? See, there are no repeated x's here, so we know it's a function no matter what. If we look at a graph, we're looking at something called a vertical line test. So in other words, anywhere that I draw a vertical line, it can't hit more than one point in the relation for it to be a function. So I could draw any vertical line here, and it's not going to hit any one of these dots any two of the dots at the same time, and so it passes the vertical line test. This graph here is the graph of a function. And then a mathematical model here, a lot of times mathematical models, we end up relying on the graph of the function in order to see that it is indeed a function, because once we plot the picture, then we can see if it passes the vertical line test. Now, from a description, the words, right, trying to model that and then going for a graph is usually the way that we decide if it's a function as well. Now, our next examples here are going to be looking at the different parts of the rules of four and deciding whether it's a function. So on the left-hand side over here, I have a table, and the right-hand side I have a table. The left-hand side is a function, and the right-hand side is not a function. So look at the left-hand side. We have x's 1, 2, and 3. They're all unique x's. That's how we know that this is a function. Over here you see I have the same x twice, and it goes to two different y's. That means the right hand side over here is not a function. This is a picture that shows ordered pairs.